Let's look at this example. In a study of 420,095 cell phone users, 135 subjects developed cancer of the brain or nervous system. Suppose there is a 0.034% cancer rate of non-cell phone users. Test the claim that the cancer rate of cell phone users is different from that of non-cell phone users. We'll use a 0.005 significance level. So the claim in this case is that the cancer rate of cell phone users is different from that of non-cell phone users. So my claim is that P does not equal the 0.034%, but I'm going to change the percent into a decimal. So move the decimal place to the left 2 places, and we have P does not equal 0.00034. The opposite of not equals is equals. So now let's identify the null and alternative hypothesis and decide which one corresponds to the claim and which corresponds to the opposite. Well, in this case, the opposite has the equal sign. So our null hypothesis will correspond to the opposite, and the alternative hypothesis will correspond to the original claim. Now, since the alternative hypothesis is not equals, that tells me it's a two-tail test. So let's calculate the test statistic for this sample. P hat in this case will come from my sample 135 subjects that developed the cancer out of 420,095 cell phone users. P in this case of course comes from the null hypothesis 0.00034, and Q then is 0.99966. N of course is 420,095. So plugging all this in, I get a test statistic of negative 0.66. So I'm going to take my significance level and split it into the two tails because this is a two-tail test and I want to use the critical value method. So I need to find the critical values that have 0.0025 to the right and 0.0025 to the left. So let me look up 0.0025 in my normal distribution. 0.0025 is here, and I see that the z-score that corresponds to that is negative 2.81. So I got negative 2.81, but of course since this is a critical value, I have the plus and the minus version. So our test statistic, negative 0.66, is not in the critical region because it doesn't fall farther to the left than negative 2.81. So let me say that again. Because this is a negative test statistic, I want to compare it to my negative critical value. If it's further to the left than my negative critical value, then it's in the critical region. Suppose my test statistic was positive, then I'd compare it to the positive critical value, and I would look for if my test statistic is in the critical region to the right, that is further to the right than my critical value. So since our test statistic was not in the critical region, we're going to fail to reject the null hypothesis. So now let's interpret that. Looking back at the beginning, I failed to reject the null hypothesis, so let me cross out the alternative hypothesis, which corresponds to the claim. So since I've crossed out the claim, I can say effectively that there's not enough evidence to support the claim that the cancer rate of cell phone users is different from that of non-cell phone users. So if we took this interpretation further, basically what we're looking at is, according to our sample, doesn't seem to be a higher instance of cancer rates for cell phone users. So you can safely use your cell phone without the risk of brain cancer.